Hello to everyone and welcome to Urbano Hydra Essential Training. My name is Rino, and during these 3 training sessions, each one lasting approximately 2 hours, I will show you how to work with Urbano Hydra. After you complete this training, you will be able to create new water distribution network with Urbano, draw everything in plan and profiles, analyze the network for pipe crossings and clashes, calculate water demands, and run hydraulic calculation. Today, we will start from the top and we will learn the very basics of Urbano. We will talk about drawing the network in plan and profiles, setting pipes, manholes and trenches, analyzing the network through data tables, labeling the elements, precisely defining pipe elevations, changing visual appearance of the elements, and many other things. Each session will last approximately 2 hours, and after that we will have Q&A, and I will answer all of your questions. So let's start with the Urbano Hydra Essential Training. Urbano Hydra is AutoCAD-based software for detailed design, analysis, and hydraulic calculation of water distribution networks. It works on top of AutoCAD, but also on top of Map3D or Civil 3D. So if you run Urbano on top of Civil 3D, you will have the advantage of using Civil 3D DTM surfaces. So here we are in Urbano. I'm using it on top of Civil 3D 2022 version, and this is Urbano user interface. We have the main workspace, we have Urbano ribbons, we have this disk repository, and this is module selection. So I have here one drawing. As you can see, this is basically just the raster image of the area where we are going to design this network. But also let's check what else I have in this drawing here. So let's open the layer manager from AutoCAD. And here you can see that I have some layers named with the prefix of DTM. So let's turn on these layers. And also I will turn on this layer called Civil 3D DTM. So when we talk about DTM in Urbano, you can use Civil 3D DTM surfaces if you, like I said, run Urbano on top of Civil 3D. But also if you run Urbano on top of plain AutoCAD, you can create basically this same DTM surfaces using our own DTM modeler, which is called Terraform. This part is not the one of the topics of this training. So if you need help creating DTM surfaces with Urbano Terraform, or if you want to know more about Terraform, we can discuss this on another occasion or after this training. So during this training, I will use Civil 3D DTM surface that I created using these elements that you can see here. So we have some points, 3D points, and also some lines with elevation representing these roads of this area. So if I switch to 3D view, you will see this Civil 3D DTM surface. So as you can see, this is a thin surface. So that's basically all that we have in this drawing. So let's switch back to 2D view, and let's now start doing some stuff with Urbano. First of all, I will turn off these layers. I just wanted to show you that we have some DTM here. And I will turn on some of these helping layers that I have here. So I have some description, some AutoCAD polylines, some helping points that will help me to create this water distribution network. When you open Urbano software, you will notice that the main workspace is empty. And that is because you have to create a system. So basically, you can see that all other icons are grayed out. That means that you have to click here to create a new system. When we talk about creating new system, you can create new system from some predefined template, or you can create a new system without a template. It's basically up to you. I always prefer to create a new system based on a system template. The only difference is that if you create a system based on a system template, you will get all the predefined configurations of, let's say, data tables, labels, profiles, cross sections, and stuff like that. So the difference is, if you like to have some stuff predefined, and then you can delete the ones that you don't need, or you can go the other way and basically start from blank system and then call and create new configurations as you need them. So to create a new system according to system template, in this case, we will create a new water system. So just click on this template here. And you will see in a second that new system will be created with the default name for water. And here you can see what I told you, that these definitions that we call configurations are already defined. So you have configurations for data tables, for the labels, for the long sections, or for the profiles, thematic mappings, cross sections, and stuff like that. Let's now check the other way how you can create a system. I will create it in the same drawing. So again, I will click here and I will click on new system. If I click on a new system, the software will ask me to fill out these properties. So what will be the name of the system? Let's call it, I don't know, water 2. We can put some description. For the type of the topology, this is line or network topology. This is all the pipe infrastructure topology elements. A polygon topology would be for parcels, and non-topology system would be for some detailed assembly schemes. So for the network topology, we use this line network topology. For the topology type, we have to choose between type of the pipe infrastructure, so sewage, water, gas, vacuum sewage, or geodesy. This is surveying module. So we will use water distribution network. And this is interesting. This is it's called invert position, but invert is usually the bottom inner point of a pipe. But in Urbano, you can define what will be your, let's call it, invert position. But basically, this is not the invert position. This is the what will be the referent point on your pipe where the pipes will connect when the diameter changes. So for example, you have a pipe of 200 reducing to pipe of 100. What will be the point where these two pipes with different diameters connect? And for the water distribution network, I like this point, this invert position, to be axis, and this is default. If you are not, if you don't need these pipes with changing diameters to be connected at the axis, you can use some other point of a pipe to represent your invert position. It's just some parameter that you can set up, but you will see later that basically it's just a default. Okay, I will leave it to axis. And also one more thing why I like to use axis, because when you later export the network to EPANET, and when you calculate hydraulic calculation, as you know, in EPANET, you don't have elevations of the pipe center line, elevations of the pipe top, elevations of the pipe bottom, elevations of the invert, I don't know, terrain elevation. In EPANET and other hydraulic modeling softwares, you only have the data elevation. So what will be that elevation? So that elevation will be the thing that we define here. So that's why I like, for the water systems, I like to use axis, because that's how I know that the center line of the pipe will be exported as the elevation to EPANET. Okay, you can also set up coordinate system, but we don't need this now. Let's switch now to layers. You will see that layers are predefined in Urbano. You cannot create your own layers. Of course you can, because you are in AutoCAD, but you cannot switch Urbano topology to be on some other layer. So these layers are predefined. You cannot delete them. You can delete them, but the software will recreate them. So don't delete them, don't rename them, because each layer is named so you know what is, so that the software knows what is on that layer. You always have as prefix is the system name. So now we rename the system to water, Now I will click here to recreate layer names. So now it will be the system name, then underscore, and here you have what is on that layer. So sections, nodes, some labels, longitudinal sections, and stuff like that. And then you have the ID of the system. Always the first system is ID 0, the next one is 1, and so on and so on. Also here you can set up the colors and line types and line widths for your system. Okay, let's click OK. And now you see the Water 2 system is created. And now if I go to previews, there is no predefined configuration. Labels, there is no predefined configuration. But it's not something that you cannot create, of course. You can just click here with right mouse button, for example, for the previews on the sections, and here they are. These are the configurations from country kit that are saved in the installation. So if you create it by template, you will have all these configurations already created. And if you create a system without template, you will just have to click here and call. For example, I need section geometry. I need section hydraulics, for example. I need pipes data and excavation data. For the nodes, I need node geometry and let's say manholes. For the labels, I will create just this label. So it's just a matter of your preferences. If you like to have everything and then delete the ones that you don't need, or you like to start from scratch and create just the configurations that you need. Okay, to delete system, right mouse button on the system and delete selected item. So that's how you can delete the system. This will be our main system, our system water that we created. And now we can start designing the network. When we talk about drawing the network in Urbano, there is three main ways how you can draw the network. First way is by interactively drawing in plan. Second way is by conversion of AutoCAD elements such as lines or 2D or 3D polylines. And the third way is by importing from some external source. These external sources can be, for example, Esri shapefiles, it can be various SQL databases, it can be plain text files, and also it can be EPANET EMP file, it can be LandXML, and also some other file formats. Okay, so I mentioned before that we have ribbon and we have our workspace. All the commands are in the main workspace, and some of the most commonly used commands are also exposed on the ribbon. So for example, for the drawing functions, if you right mouse button on the main branch draw, here you have draw network elements, conversion of CAD elements. And of course you have them here. So draw elements, conversion of CAD elements. You will notice that sometimes I will show you and I will start commands from the main workspace, but I just prefer using it from the ribbon because it's just much quicker. So let's start draw elements. And here you can see that this is a quite large dialog because many different options can be set up here. Also, it's important to say that when you move the dialog places and also the settings that you define, everything is saved in the dialogs and everything is saved in the application. So the next time when you open Urbano, this dialog will not be on the center, it will be here. So this is really nice feature. So you can see here that many different options can be set up here. For example, you can automatically label nodes and sections with some of these predefined configurations. You can also automatically set the pipes from the pipe catalog. The same is for the manholes. For now, I will keep everything blank. We will set up this later, but just that you know that while drawing, you can automatically basically set everything from pipes to manholes, to labels, everything. I will just define terrain elevations from DTM. So for the DTM type, I will choose Civil 3D, But here you can see what I showed you before. You can use Civil 3D if you run Urbano on top of Civil 3D. And if you work on plain AutoCAD, you can work with Urbano Terraform or even 3D faces created with some third software. That's also allowed. I will use Civil 3D, and I will use this surface name that I created before and that I showed you. Also, this is very important. Draw additional points. Additional points are basically the points where the sections, where the pipes that you draw cross the triangles of DTM. So of course that you would like to have this turned on always. It's recommended that you have this turned on always, because you will have more elevations on your profile, on your pipes, because if this option is turned off, you will have only elevations in the nodes. But if this is turned on, each point where your lines are crossing the triangles of DTM will be calculated, and here you will also have the elevation in profile. So this is something that I always keep turned on. For the invert elevation, okay, I would like to set invert elevation. You can see here that the referent pipe point is axis. So I will set that the center line of my pipe, when I assign the pipes later, will be 1.5 meter below the terrain. Okay, so let's now click draw. So I will click here on draw. Even if I didn't assign the DTM elevations immediately and invert elevations, you can set up everything later. For example, you go to input data and you can set up the terrain heights and invert elevations and pipes and manholes and everything. So that's why I didn't set up the pipes and the manholes. We will do that later, but I decided to immediately set terrain elevations and center line elevations of the pipe. So let's click now draw, and now I will use plain AutoCAD OSNAP to connect to the centers of these circles, these helping points. Sorry, I clicked here unintentionally, so you can see one node is here. So to delete something that maybe you unintentionally draw, don't use AutoCAD, just delete, because it will not be deleted from Urbano internal database. Here you have the icon for deleting elements, and you can delete it like this. Okay, so now let's actually start drawing. I will click on draw, and I will snap to the centers of these circles, and you can just continue drawing. Let's check some of the other options that you have here. One of these options, really important option, is the buffer distance. You can see, if we continue drawing, that this yellow circle appears when we are near the existing node. So if I would like to now click anywhere inside of this yellow circle, the software will not allow me, because this is the buffer zone, and it's basically as AutoCAD OSNAP. So you cannot draw inside of this circle. And this is the buffer distance. I like to reduce this number to 5 or 2, because this is just, maybe this default is too much. So I like to put it to 5. And now you can see that this yellow circle is smaller. Other options that you can use from this dialog, which are really interesting and useful, especially while designing water systems, is use default angles. You can turn on this option, and here you can define, you can just type the angles that you need, and then the software will allow you to draw only using these angles. So let's now check this. Now you see this compass, and I can draw only in these directions. Like I said, you can even type some additional angles here, like for example 22.5 or 60, and then you will have much more of this compass directions. So the draw functions the same. You can just click, and here we are. But I don't like to use this option, because then you are very limited. So I will turn this option off, and let's continue drawing. And notice in the tooltip how the terrain elevations are automatically read from the selected DTM, and the invert elevations or center line elevations are automatically calculated 1.5 meter below the terrain. Okay, now we draw one part of the network, and you can see that by default for the water system, the nodes are yellow and the lines are this cyan color. Because I work on this white background, because I think it's better for trainings and presentations, I will have to change these colors. Of course, these are plain AutoCAD elements. As you can see, these are lines. Like I said, Urbano is AutoCAD based application. So these are lines and these are plain AutoCAD blocks. So if I want to change a color of a layer, I can open the layer manager and change these colors here. But this is not recommended, because if you do it here, if you do it with AutoCAD, you will just change it in your current drawing. So later on, if you export this to some other Urbano drawing, you can do this. You can export from one drawing and import it to another drawing, and then merge multiple systems and stuff like that. Then these colors will not transfer because they are saved only in DWG. So to change color of the layer, go to the system function here and edit, like I showed you before for the system number 2 that we created. So here we will go to layers. Like I said, we can also give it a new name. For example, let's call this, because this place where we are designing this network, this is in Croatia, I will call it Novi, like Novi Vinodolski. And be sure to always click here, recreate layer names, so that the prefix is the name of the system. And now you can change the colors. This is the colors of the sections. Let's change this to this 150, a little bit darker blue color. And for the main nodes and the plain nodes, I will explain later which ones are mains and which one are plain. I will change this also to some colors that we can see much better on a white background. So main nodes will be red and plain nodes will be, let's say, this magenta color. Okay, let's click OK. And now you see that this is changed here. And of course, it's changed in the AutoCAD layer manager as well. So this is something that is really important to know, that even though you work on top of AutoCAD, you have to use Urbano functions to do some modifications. Okay, so we have drawn one part of the network interactively. Let's now convert this part of the network from plain AutoCAD objects. So let's select some of these polylines. And here in AutoCAD properties, you can see these are plain 2D AutoCAD polylines with no elevations. And now we will convert them to intelligent Urbano topology. Okay, also, if you want to increase the line widths or line types, change the line types, you can also do it here. Now I notice that they are still not as visible as I would like to have them. So let's go to edit, let's go to layers, and for the sections, I will change the line width from default to 0.3, and also I will do it for the nodes. That's how we will see these elements much better on this white background. Click OK, and now this is much better. Okay, the second function, which I said for drawing, is drawing by conversion of CAD elements, or you can start it from the ribbon. So this is it. You can see that many of the same options can be set up here. You can automatically define terrain elevations. They can be from Z coordinate if you have 3D polylines, or in our case, we have 2D polylines, so we will set elevations from DTM. DTM type will be, again, Civil 3D DTM surface. And of course, we will use additional points. We will not set up pipes immediately, but we will define center line of our pipes to be on a constant depth below terrain of 1.5 meters. For the labels, we will keep it empty. And also, this is really nice option, create arrays from polylines. Keep this turned on. I will show you what are arrays a little bit later. So each of this original polyline will be saved as something that we call array, which is very useful for later drawing of the profiles, selections, inputting of data, and so on. Also, for conversion of CAD elements, you have this really nice options for layer filtering. Because just imagine if you have here many different layers, you don't have to turn them off and then turn them back on later. You can just use this layer filtering. You can pick the layers from the list, or you can, with this icon, select the layer from the plan. That layer is recognized, and now you can freely select the entire drawing, and the software will select just those elements on defined layer. And now we can convert this, and everything will be converted from plain AutoCAD polylines to intelligent Urbano objects consisting of nodes and sections. Okay, let's now turn off this AutoCAD layers that I previously turned on, this description, original polylines and helping points. We turn them off, and now we have only the Urbano network showing here. And like I already showed you before, these are lines on separate layers. And now I would like to emphasize some rules. I already mentioned the rule about layers. So each of the element has its own layer. So I will repeat once more. Do not move this to some other layer. Do not rename these layers. And also do not, I don't know, delete layers or something like that. This is just a rule that you have to work by. The second rule that is very important is that even though we are working in AutoCAD, you cannot use AutoCAD commands like delete, move, copy, rotate, scale, and stuff like that. You can use them, but you will be just changing the DWG. You will not be changing the Urbano internal database. So you can treat it like this. AutoCAD is just serving as a graphical interpreter of Urbano model. So look at this. If I take, for example, this part here, and I use AutoCAD move, and if I move it, for example, here, and then I click here on reindex or refresh, redraw the model, it will reappear here because inside of Urbano database, this is here. Also, if I, for example, delete something, I will delete with plain AutoCAD, just delete, okay? You see this is gone, and maybe you think, okay, I deleted this completely. If you click here on reindex, or for example, if you save this drawing, close it, open it back again, the software will reindex the drawing while opening, and you will have this back on. The same goes, I don't know, for rotate, or copy of the elements. For example, I can take some of this and I can copy, and I can copy it here, okay? And now if I click on redraw, everything will come back, and this is just dead elements. This is not part of Urbano model. So let's delete everything and redraw. You will see that this will not come back. So this is the rule number 2 that you have to know. I will show you. You have, of course, you have moving, you have deleting, you have rotating, you have even scaling. So everything is available, but with Urbano commands, because if you are just changing the drawing, if you're just changing the DWG file, you are not changing the model. So this is the rule number 2 that you have to know if you want to work properly in Urbano. Okay, let's now analyze this system that we created. Always the best way to analyze Urbano network is by using data tables. These data tables, I will show you later how you can create your own configurations. But for now, let's just use the ones that we have here that are predefined from Country Kit. You can just double click on them and they will open. For example, let's double click on section geometry. And here it is. You have the, for example, for the sections, you have all the data that you might need. Of course, you can add some other data. You can delete some data. Here we have names, starting and ending nodes, lengths, starting and ending elevations. These are the center line elevations, diameters that we didn't set up yet, and so on. But If you just double click on these previews, you will see that they are, we call them static data tables, because as you try to click somewhere else, you will not be able to, because they are just, we call them previews. So you can check the data, but you cannot work while this table is turned on. If you want to have them as flexible data tables, you have to click here on this icon, which says show data preview. And I always prefer to use it that way. So if you open it, you will see that the data table will appear here. You can position this. You can also define the position of this this window. You can dock it anywhere to any part of the screen. You can even put it on the, if you have two screens, you can put it on another screen. But I like to have it here. And also all these configurations are here, so you can just easily switch between them. Let's again select section geometry. Let's select the entire network. This is this icon, this yellow icon. You will see it all over the program. This means select the entire network. So click here and you will see the entire network. And now we come to the third main rule for successful using of Urbano, and that is selection options. And here you have all or almost all of Urbano selection options. It is important to know how to select elements in Urbano. And again, I'm repeating, even though we are in AutoCAD, you cannot just select these elements like this and expect, so what I did, I just selected it like this. You cannot expect that Urbano will know what you selected with AutoCAD. It's just not how it works. You have Urbano selection options that you can use for selection. So first of all, in each function, first start the selection option and then select what you need to select. And even if you want to use CAD selection, here it is. Here is the CAD selection that will tell the Urbano function what you selected. So CAD selection, and now if I will select this part here. Now we see that we have only these elements in selection. Also, I like to use these options for marking. You have mark none, so nothing will be marked, marked just in plan, mark just in profile, or mark both. I like to use mark in plan. And now you can see what is selected in the data table is marked in plan as well. And again, you see that this is yellow color. And again, this is all these colors are meant to use on a dark background. And because I'm using the white background, I will also show you where you can change this in case you also work on a white background. So to change this highlight color, and you will also see many other colors, you can click here on settings, and here you can click on general settings. And here many some parameters can be changed, but we are interested in colors. So let's just search for color. And here you can see all the colors in Urbano that can be changed. These are various colors, for example, colors of selection, of temporary highlighting, of permanent highlighting, of temporary selections and stuff like that. I will not go too much into this. I will just change all the yellow colors that I see here to red, because red is very good, will be very good visible on a white background. So this is everything I will change to a red. This is here also yellow. Let's change it to red. This is also yellow. Let's change it to red. And also, I think this cyan color will also be problematic for a white background. So let's change this to dark blue. Okay, this one will also be dark blue. And here, this one will also be dark blue. You can check this by yourself and try changing and see what will happen. We will not go too much into this. This is not just that important. Okay, and now you will see that now these colors are red and they are much more suitable for the white background. Okay, so this is AutoCAD selection, but also you see many different selection options. For example, selection of sections. So section is basically, it's not a pipe, because you will see later that we will set pipes from pipe catalog to sections. You can treat this, for example, like in EPANET, it's a link between two nodes or two junctions. So if you go to selection of sections, you will see that you can select, for example, I will select just these 3 sections, and here they are. Also, let's switch to a different data table. For the nodes, let's go to node geometry, and let's select few nodes. Let's select this node, this node, this node, and this node. And now you can see the data for the nodes. We see names, coordinates, terrain heights that came from DTM, node type, and node type main or plane. And now here you can see which are main and which are plane nodes. So, and you can see this in colors as well, because we define that the main nodes are red and the plane nodes are purple, or this magenta color. What is the difference? So by default, the main nodes are where you started drawing. We started drawing here. Where you ended drawing, so we ended drawing here, and also all the branching nodes. So here we have a branching. This is a main node. Here we have a branching. This is a main node. So this is something that enables you quicker selection as well. So let's now go again to section geometry, and let's now check the selection of branches. So basically, what is a branch? A branch in Urbano is everything in between two main nodes. So just like the word says, a branch. But also it's interesting that you can also go to function for editing of the branches, and you can break these branches, and basically this node will change. If I break this branch here, this node will change from plane to main, even though it's not a real branching. But of course, if I try to merge this branch with this branch, it will not be allowed by the software. So for example, if I select this branch, and this branch, I will get selected all the sections that belong to these branches. So it basically enables much quicker and intelligent selections. And also we have the special data preview according to branches. So if I click on a branch geometry, you can see the total group data for the entire branch. So this is also interesting. And then we also have something that we call arrays. Arrays are basically arbitrary topology selections or topological elements that basically you can merge them, you can break them and create them as you like. So like I said, by default, if that option that I showed you is turned on, one original AutoCAD polyline will be one array. And you see, these are the arrays. These are the arrays, and this is the array that we drawn interactively. But like I said, you can merge them, you can break them, and you have more freedom than with the branches. So for example, if I select this array and this array, I will get all the sections that belong to these arrays, and also I will get all the branches that belong to these arrays. Let's also create a data table according to arrays. So to create a new data table, click here with the right mouse button on a sections and click new. I will call this new data preview arrays. And here you see a scope which says scope is section, branch, or array. So if this is by sections, you will see each section. If this is by branches, you will see sections grouped as branches. If this is arrays, you will see the data for the entire arrays. Okay. Here, this is data picker, as we call it, for selection of the data. You will see this multiple times today. So when you want to add data that you need, you can search for it. So for example, this is the name, the data that I need, array, and you can just click here on this arrow to put it on the right. And for example, this is the section name, which is always by default here. I don't need this, so I will, with this arrow, remove it. Also, it would be good to have the length of an array. So I can search for the data. I will just type array, and here it is, array length. So this is for the filtering of the data. Array length, I can click on this arrow, or I can just double click with the left mouse button on the data. And here it is, array length. You can also keep adding the data, but this is enough for now. I will show you later how you can add more data as well. Okay, let's click OK. And let's now find this new data configuration that we created. Let's go to arrays. And now here you can see that we have the entire data for the data for the entire array. So let's select, for example, the whole network. And here you can see array by array and their total lengths. It is important to say that these data tables are not used just for previewing. All the data that is white here, this can be changed as well by double clicking inside that. So it can be used for previewing. It can also be used for data inputting or data editing. But first, before we rename them, I would like to merge these two arrays. This one that we created, that we drawn interactively, and this one that we have drawn by conversion of CAD elements. So for now, this is two separated arrays, but let's merge them. To merge them, I will go here to function for editing of the arrays on the ribbon, or you can go from the workspace to editing and editing arrays. So you can see the same function on multiple places. Let's position this dialog also on the right. And I would like to use option for merging. So let's select this one and this one. We can give it a new name. Let's call it A1 and let's click apply. And now here you can see that this is now one array. It says array successfully merged with the other one. And now if I go here to selection of arrays, you will see that this is one array. And we named it A1. Let's also rename all the other arrays. Like I said, you can use data table for that, but also there is much more better, quicker, and more intelligent option. For example, option for renaming automatically the arrays. So you have your selection options. You can select the entire system, but I will go with the selection of arrays because I would like to select just these horizontal ones, and I will give it a different prefix. So here you can see the pattern for renaming that you can use. You can use many different patterns. For example, you can use starting node name of an array and ending node of an array. So basically your array name can be from starting to ending node. But I like to name my arrays so I can easily know which one is which. So I will call all these horizontal ones with the prefix H. So H1 to H4. Many of our users also call these arrays according to street names. This is something that you can also do. Let's click apply. And let's also select now these smaller ones, these 4 horizontal ones. And I will give it a prefix V. And let's click apply. Okay, let's close this dialog. Here, let's select the entire system. And now, if I sort it, you can sort by any data. If I sort it by name, we see this is H1, A1. We have these 4 horizontal ones from H1 to H4 and 4 vertical ones from V1 to V4. Okay, let's now label the elements in plan. So just like for the data tables, the same is for the labels. By default, you have many labels that are already predefined. Later, I will show you how you can also create your own label configuration. But for now, let's use the default ones. So for this section, I would like to use this one, length and direction. And also you see these stars. The stars are basically the one that is default. So for example, I would like this number 2 to be default. Right mouse button on it and set it as default. And also for the nodes, I would like to use this name, terrain, and invert elevation or centerline elevation. I will select this one, right mouse button, and set it as default. Why are these stars good and useful? First of all, I always like to label as default the one that is applied so that I can always know which label configuration is currently in the drawing. And the other way why this is important is that you can run the labeling of the entire system with just one mouse button. So I will show you that as well. So the main way how you can label the elements is by double clicking on your configuration, any of this one. It doesn't have to be the one with the star. Double click on it. This dialog opens. And now you have your familiar selection options. Always by default is the yellow icon, which I said means the whole network. So active system. And now when you click here on this mark icon, everything will be labeled with that label. So we have lengths and we have the arrow of direction. And like I said, the other reason why you would like to have these stars, I will now show you. So I can start this again by double clicking, selecting, and clicking on the Thunderbolt Thunder icon. Or you can go to ribbon, and here you see automatic labeling of nodes, automatic labeling of sections for the entire network with the default label configurations with the ones labeled with the star. So let's label the nodes. So I will just click here on the ribbon and the whole network is labeled with this configuration. So you can see the node name, terrain elevation, and invert elevation. In this case, this is a center line elevation. Okay, so now that we labeled the nodes and sections, we see the names of these nodes. And you will notice that by default, these names will be, okay, they will be some prefix as n, as node, and some counter. You will see that this counting of the nodes will not always be as you might expect. That's because this is very easy to change later. So one of the really nice options in Urbano is the options for renaming of the elements. So in the data table, let's switch to node geometry. And like I already said, all the cells in the data table that are white, you can edit them directly typing in the data table. For example, let's change the name of this node. I will change it to tank, for example. Okay, and notice how the label and basically everything in Urbano is dynamic because you change it, for example, in the data table, the model automatically updates. So both plan, profiles, and data tables are completely synchronized. So this is how you can rename using by data tables. But also if we go to our option for editing of the nodes, we can go to function for renaming automatically or renaming by arrays or branches. If you go by rename automatically, you know the procedure. You can set some prefix for the main and for the plain nodes, or you can put the same prefix, select something and rename it. But what is more interesting to me is this renaming by arrays by branches. So you can select the entire system, and for the prefix, you can use the array name or the branch name. I like to use array name. So as prefix, it says here to use monkey to insert array name as prefix. So I will put a prefix of an array, and also I will put point as a delimiter, and click here. And now you see this is the order: A1, then H1 to 4, then V1 to 4. And let's click apply. Okay. And now notice each node in the plan and in the data table is named according to the array. We have the prefix A11, then A12, A13, and so on. And then when we come to branching here, you see this is A18, and this is here H11. Why is that? Because here in the list, A is before H. If you want to reverse the order, here you have the move up and move down icons. So H is before V, so H2, H13, and this will be V11. So this is how I like to name my nodes, but you can also name it using some other rule as well. Let's now also rename our sections. So let's go to section geometry. Default is some prefix S, and then you have your counter. But let's check what are the possibilities. Let's go to renaming of the sections or editing sections. And here, let's switch to rename automatically. And very similarly, like for the arrays, you have your patterns here. So you can use different patterns for prefixes, suffixes, or combination of them. For example, you can put branch name, array name, you can use from starting to ending, node name, and so on. So for example, let's select the entire system and let's rename it. So from start node, which is monkey 3, to end node, which is monkey 4. So let's type here from monkey 3 to monkey 4, and this will be a new name. So you can see here in the preview, this is the old name, this is the new name. And let's click apply. And now you see how this is renamed. You see the name of each section is from starting node to ending node. You can leave it like that, but I will use some other rule because I already have in my data tables what is my starting node, what is my ending node. So I will use some other rule for naming of the sections. And if you want to use it like this, so from starting to ending node, then it's the same. You can select the entire system. But if you want to sort it somehow, you have to use selection options because selection options are sorted. So let's say I will select this one, then the 4 horizontal ones, and then 4 vertical ones. So this will be the selection order. And for the prefix, I will put S like section. And for the counter, for the suffix, I will put counter, which is monkey 5. As you can see here, monkey 5 is counter. Okay, let's click apply. And now you see it's from S1 to S64. Okay, and if I sort it now, you can see that this is the order. So from S1, we have this main array, then we have these 4 horizontal ones, and then we have these 4 vertical ones. The very same is for renaming of the branches. For example, let's also do that. So we can go to editing of the branches. Here you can see the many different functions for merging, for breaking, for reversing, but let's go to rename automatically. You can see all these dialogues are the same. So let's here go to active system and let's use this from starting node to ending node. So let's type it monkey 3 to monkey 4. Okay, and let's click apply. And here you see now that the branch names are according to starting and ending node names. So now that we renamed everything, and now that we have our topology, Urbano topology familiar, we can go to some other functions. And one of this function is drawing of the profile. Of course, you didn't have to rename anything to draw profiles. You can draw profiles immediately. But I wanted you for you in this basic training to learn the topology, to learn the selection options, because now you will see how it's easy to use them to achieve some great things. For example, with these selections and knowing the topology, you can very quickly set or edit a lot of amount of data. You can quickly draw the profiles and so on and so on. So let's now close our data table and let's draw the profiles. So again, just like for everything, you have different configurations here. I will use the configuration in centimeters, which means that it is 10 times smaller than the lengths in plan. You can also use it in millimeters. In that case, it will be 1-to-1 with the plan. But some of our users and I also like to have the profile smaller. So I will use this configuration, and I will show you later. Inside of this configuration, everything is stored, from the scale, from the colors, from the data, from the language, basically everything. So double click on it, the dialog opens, and again you have your familiar icon here for selection. And now, because we defined our topology by arrays and by branches, we can easily just click here for the entire system and tell the software, draw me all the profiles in my network based on array topology or by branch topology. And here you can see the names of the arrays that we defined. And now you can just click on draw and get all of the profiles drawn according to array topology. So here we have just 9 profiles, but it's the same if you have 9 or if you have 900. So it's in Urbano, you can have literally any amount of profiles and they are drawn very, very quickly. So I will also define row and column spacing between them. I will put them, you can put them in the grid, or you can put them all vertical or all horizontal or in some kind of matrix. I will put them in 5 rows and 2 columns. I will set spacing between them to be 50. So a little bit larger spacing between them, because later you will see that our profiles will expand when we run hydraulic calculation, because also the piezometric lines will be showing in the profiles as well. So be sure to put a larger spacing in between them. Then maximum dimension for all frames. This means that all the profiles will have the frame of a maximum profile. So the profile with the maximum size, all the profiles will have the same frames. But I like to use frame dimension, which means that each profile will have its own frame dimension. And now we can click on draw. Let's place it here. And that's it. So that's how it's easy to draw all the profiles in Urbano. And you can see the terrain line that came from DTM. We see the center line of the pipe. We didn't set up pipe yet. And also all the data is here. And I will show you that everything, so to the smallest detail, everything can be changed and edited inside of these configurations. And the other way, how you can draw these profiles is by, of course, you can draw it always by arrays or branches, and you can select the entire system or some other selections, or you can go from node to node. This is great selection option. I didn't show you before in the data table, but you can use it also in the data table. Really nice option. You click from node and you can go to any node in any direction. But notice that the software is always searching for the smallest path between 2 points. And also notice the profile. Notice how I am going in plan. Also, these elements are labeled in the profiles as well. So this is a feature that can be turned on or off. I usually turn it off because I find it somehow confusing at sometimes, but also it can be useful to see which elements are which. but now you can see that I'm here in plan, and these same elements are in multiple profiles. So I usually turn this option off. I will show you where. So to turn this simultaneous mark, you can go to settings. We can go to general settings, and here you can search mark. And here it says mark all displayed entities. Turn this off and click OK. And now notice when we go from node to node that we do not have this simultaneous marking by default. Okay, and notice that always the shortest path between 2 points are selected. So if you want to go to your defined path, you can click multiple points on the way. So I will click to this node, and then the software will know that it has to go through that node as well. So all up to this node here. Okay, right mouse button, draw, and let's place it here. I will use just OSNAP with the endpoint and with the extension. So I will put it to be also 50 units above it. So that's it. And now we have one more profile, which is drawn from A11 to H412. Okay, and now I would like to show you how you can edit this profile configuration. So basically, like I said, to the smallest detail, everything can be changed. How to edit the configuration? Right mouse button on it. So you can click on the one that you want to edit. Or if you don't remember which one is applied in the drawing, you can click here on the main branch and click edit configuration. And then the software will ask you, okay, but which one? And then you select on any profile, because in this case, all of them are drawn with the same configuration, but you can even have multiple configurations in the same drawing. So the software is asking, select one of the profiles. I will select this ones. And then the software knows that this is this configuration here. When we talk about profiles in Urbano, this is probably the most complex function. It's not hard to use, but if you check it, basically, like I said, all to the smallest detail can be changed here. So how to know what you want to change? Of course, if you are an experienced user, you will immediately know where to find some data. But if you are a new user, like probably most of you are or will be, you will need some quick selection to select something in the profile that you want to change. And that's why we have this interactive select button. So just click on it and then click on any part of the profile. For example, I would like to change this terrain line. Let's click on it, and the software takes you where this data can be changed. So you see this is a green line. Let's change it to be the color 32, which is brown color. And now you can click OK, and you will close this dialog, and this will be changed. Or you can just click Apply and continue editing while seeing how it looks like. So if you're satisfied, let's now go on. Let's again click to Interactive Select. Let's maybe change this cyan colors of the names and the scale. So let's change this to dark blue color for the name. Okay. Again, let's click on Interactive Select. Let's click here. For the prefix of the scale, I will change M to S, and I will change the color from cyan to dark blue. Okay, and let's click Apply, and this is changed to blue color. Also, it's not just for the graphical elements. You can also pick on any numerical or this data in the profile table. You can click on a header, or you can click on the data itself. For example, let's click on this yellow line here. So this is the length slope data, and here you can see slope line color is yellow. Let's change it to black. Okay, and that's how you can basically edit all the parts of the profile. So for example, let's click here on the header, and here you can see that this is a row header, and here you can change anything. Let's click OK. So that's about it for editing of the configurations for now. Day after tomorrow, when we have additional topics, or I like to call it advanced training, I will show you some more advanced stuff about editing of the data tables. And also, I didn't say, but this data that you see here are not fixed. So basically, here you have many data. If you again go to this data picker, any of this data, you can delete it, and you can add some other data. I don't know, maybe some hydraulic data, or data about excavation volumes, or I don't know, data about intersections or crossings with some other infrastructure, or basically any data that you might want to have in your profile tables, you can have it. So let's click OK. Okay, so now that we defined the profiles, we drawn the profiles, let's also set the pipes. But before we set the pipes, let's save now this drawing. We have been working more than 1 hour, so I think it's a good time to save it. So let's save it, and I will call it Urbano Hydra working. Okay, so I already explained that the main topological elements of Urbano model is node and section. These nodes and section can have pipes and manholes, or they don't have to have. So to set pipes and manholes to nodes and sections, we have to go to our catalogs. So here is the icon for the catalogs, and here you can see all the different catalogs in Urbano: catalog of pipes, catalog of manholes, catalog of trenches, top layers, protecting pipes, many different catalogs. So let's open catalog of pipes. And here you can see this is the catalog of drawing, this upper part. You will see that when you set some pipes from the application, they will also appear here on the top. Why is that? Because they are then saved in the drawing. Because you can create some of your own pipes, you can apply it to the drawing, and then when you send it to someone, that someone may not have the same catalog as you, but they will have those pipes because they are saved in the drawing. So here you can see all the different types of pipes available in Urbano. So of course we have circular pipes, rectangular pipes, egg-shaped pipes, I don't know, some combination of rectangular pipes with the circular bottom and stuff like that. So of course for each pipe, so these are some egg-shaped pipe. You can see the shape. You can define the material. You can define some user data like manufacturer, description, and of course all of the geometrical data like sizes, thicknesses of the walls, and so on. So let's check maybe this circular concrete pipes, or let's check maybe circular PEHD pipes, and many different pipes, shapes, sizes, everything is here. And don't treat this catalog as some standard. This is just some pipe catalogs that we defined as a default, but of course that may not be applicable for different countries, different standards, and so on. So if you want to create your own pipe catalog, of course you can edit the existing ones by just changing this data, or you can create your own catalog. And now I will show you how you can create your own catalog of pipes, because this is probably something that all of you will do. So click on Disk Catalog. This icon appears to add a new catalog group. Give it a name. I will call it My Ductile Iron Pipes. Okay. Then choose the type of the pipe. I will use circular pipes. And then click here to add a new item to that catalog. You can add one, and then of course you can define the material, you can define the roughness, you can define all the geometry data, and so on. So this is one way how you can do it. Then you can maybe copy it and just change the geometry values, the diameters, the thicknesses, or the way how I like to do it, I create the amount of pipes that I need. For example, I will create 15 new pipes. So 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So I created 15 new pipes. And now you can click here on the group, right mouse button, and you can go to edit group data. And then this will open just like Excel table with all the data here. And this is, like I said, just like Excel table. So for example, you can type the material. I don't know, ductile iron. Enter, and you are in the second cell. Or you can copy something and paste it. So basically just like you are in Excel. And not just that, you are basically, like I said, just like in Excel. So you can select the entire table, you can copy it. So I will copy it and I will go to Excel because it's much easier to edit something which is in a spreadsheet way in a spreadsheet editor like Excel. So I will open this Excel file and I will just paste this. So you have to paste the template, the empty template. So I created the 15 pipes, and here I have the pipes that I copied from my local manufacturer, because each local manufacturer has the PDFs of their pipes. So you can take it, you can copy the table to Excel, you can edit it a little bit. And now we have to structure the data like Urbano catalog requires it. So you can see these are the names of the pipes. Let's copy this here. Okay, you cannot change this because the pipes will be circular. For the material, let's copy this cell and let's paste it here. Next, we have to have roughness, and here I have roughness. So just be careful to copy the right data to right cells. So this will be roughness for the ductile iron. For the manufacturer, I don't have data, but I can type something. I know that we have here a local manufacturer called MIV, Metalna Industrija Varaždin. So I will just use that manufacturer. You can put some description as well, some standard as well if you want. And then we come to this data about geometry. So nominal diameter, or first I need inner diameter, is here. So let's copy it. Let's paste it here. Nominal diameter is this. Let's copy this. Let's paste it here. Pipe outer diameter and wall thickness. Let's copy this and let's paste it here. There is some other data that you can fill out, but you don't have. For example, some custom data if you want, or I don't know, some other data, but I will leave it empty. And now you can just select like this, the data that you edited. And now I will copy this. Let's go to our table in Urbano. Click to the first cell. So to the first cell where something will be pasted, and click paste. And now the catalog is created. So very easy, very quick to create your own catalogs of pipes. Not just pipes, anything else. And of course, let's apply this. Are you want to save it? Yes, this will be saved. And this is, like I said, catalog of application. This is not just for this project. This is now here for all of your other projects as well. And now you can see, and you can see all this data here is filled out. Okay, let's click OK. And let's go to this Excel table and let's save this. I will save this and I will close the Excel. Okay, so now the pipe catalog is defined. Let's set the pipes. So to set the pipes from pipe catalog, we have to go to function for input data, pipes, or you can start the same function from the ribbon. So I will start the pipes function from the ribbon. And here you can see that you can select a pipe group, all these pipe groups that I showed you in the catalog. So here is also the new group that we created, my ductile iron pipes, but I would like to use PEHD pipes. So I will use this pipe. So these are water PEHD pipes with the nominal pressure 10. Okay, and now we come to those selections that I showed you earlier, which are now becoming to be very, very useful. So we have the selection options. Of course, you can select the entire network and set the same diameter to the whole network. But let's use the selection of branches. And for this main part of a branch of a network, I would like to here define, let's say 315. Let's click save. Okay, now let's select maybe this branches here, and let's set here a little bit smaller pipe. Let's set 200 millimeters from the catalog. Let's click save. Notice how the profiles are automatically updating, but the pipes are yellow by default again for the black background. We will change this in a minute. So let's now continue. I will select these horizontal branches, and here I will set, let's set 180. Let's click save. Then continue to these parts here. I will set this with, let's put 140, save. And for the last part of the network, let's set here 110. Of course, we can also size the network and get the optimal pipe diameters, but this is the topic for tomorrow. Tomorrow we will talk about setting water tanks, setting water demands, performing hydraulic calculation, and pipe sizing with pipe diameter optimization. But for now, we have a basic course, basic training, so these are the basic functions. So we define the pipes, so let's go to our plan, and let's also put the diameter data in our label. So for the labels, now I would like to switch the configuration. I will use length and diameter. Double click, select it, the whole network, apply it. And that's easy how to change the configuration of the labels in plan. And also, like I said, I like to mark it as a default so that I know that this configuration is currently applied in the drawing. And you can see that now for each pipe, for each section, we have the pipe set and the known diameter now. Also, if we open our data tables, for example, for the pipes, now I'll just double click on it because I want to quickly check the data. And here you can see that we didn't set the diameter, for example, like in EPANET. We set a pipe from a pipe catalog with all the data defined in the pipe catalog. So now you see this, we define the pipe, and now inside our data tables, we see all the data about this pipe. So the section name, what is the pipe name, pipe material, nominal, inner, outer diameter of the pipe, wall thickness, roughness, pipe volume, all the data that you might want to see in the data tables. And if we check our profiles, you see that the pipe appeared in this yellow color. So let's also change this as well. So let's go to our profile configuration, right mouse button, edit. Let's use interactive select to select the pipe. And let's change all the yellow color. So this is the visible part of the pipe. This is the outside thickness, outside pipe wall. Let's put it to blue. Let's click apply to check it. Okay. And also the inner, this is dashed, but also you can change it not to be dashed, to be continuous as well, but I will leave it like that. And also midline is turned off. The midline is turned off. This, what we see here, is not the midline of a pipe. This is the, as I said, we call it invert, but it can be any point of a pipe, and we define it to be a center line. So let's click apply. And let's also use interactive select to click on this center line here. And here you can see this is the black line for the invert. And now I will explain why I like to use it to be axis. Because now if you see here, we have the changing of the diameters, And I always like in a water system that my pipes are connecting in the axis. And also later on, when we run hydraulic calculation or when we export this to EPANET, this is the elevation that will be exported to EPANET. So if you want to have it on the top outer or bottom outer or bottom inner, you can define it before drawing here in the system settings, or of course you can edit it later by go to editing and edit invert position. So this is something that it's really important to understand. But I will keep it like this. I like to have it as a center line. Okay, we defined our invert or center line position to be on a constant depth below terrain, 1.5 meter below the terrain. Okay, let's now check if maybe we are somewhere too deep or too shallow below the terrain. To do that kind of analysis, I will go to function on a ribbon for profiles, which is called Draw Auxiliary Elements. Of course, you can also go to Tools for longitudinal sections and find the same option here, Draw Auxiliary Elements for longitudinal section. So what I want to draw is some kind of a helping lines, terrain parallels. So many different helping points or lines can be drawn with this function. So you have to search for the one that you need. Let's check for terrain parallel. And now you can select just some profiles where you want to draw this, but I will select all the profiles. So let's apply it to all profiles. And now first offset line will be 1 meter below terrain. And the second line will be, let's say, 3 meter below the terrain. And now it asks also to draw additional points or not. Yes, always please draw additional points. And now when we click on draw, you see we have this helping polylines, which are basically the terrain parallels. And now we can check it and we can see if we are somewhere too deep or too shallow below the terrain. And when we talk about these additional points, previously I mentioned them, but now when we zoom to profile, you can see what are those additional points. So if we don't set the additional points, basically the line between the two nodes would be straight. So you will have only the elevations in the nodes. But of course, we would like to have these elevations in between as well. So basically, these are the points where these sections in plan are crossing the triangles of the DTM. Of course, if you notice that some points are not surveyed correctly, you can also delete some of those additional points. But it's really important to have them because later on we will also calculate the trenches and the excavation volumes. So it's not the same if this, for example, this line here is straight or if it goes up and down, because the volume calculation that we will run later, you will basically get not the right excavation volumes. Okay, so we can just change some of these positions quickly. I will show you many different options how you can do it. For example, again, we come to our data tables. So let's open again our data tables. So let's switch maybe to section geometry. And let's now use one more selection option, which is really nice. And that is selection of profiles. So let's select this profile here like this. And now we can also maybe go to marking profile and we can go and see, for example, I would like to change this section here. And here you can change starting or ending invert elevation. And in that way, you can modify the pipe elevation. But also there are many different ways how you can edit this. Some of the options are also exposed on the ribbon. You have a function for drawing the pipe position, pipe elevation directly in the profile, inputting or editing, or even if you go here, you have more functions. So interactive invert drawing, input and edit pipe invert. Those are these two. And also you have one more, which is called edit pipe invert in longitudinal section. But the point is that you can check some of this by yourself. Now I will just show you this one. This is the one that I like to use most often. I think it's the best of these three. And basically with all three functions, you can achieve the same results, but in a little bit different way. This function is really nice because it allows you to select the entire profile, or you can go from node to node in profile. For example, let's go in this profile from this node to this node, like this. And for example, now I would like to straighten my pipe between these two nodes. Of course, here you can also define what will be your referent pipe point. So if you are not satisfied with axis, so if we click here to preview, you can see here we are seeing the data. So you see depth is 1.5 for the center line. But for example, here you can change it to top outer, and now you can see the data for the top of the pipe. Here you see the depth is now 1.4, 1.4. So even in these functions, you can change this referent point. But like I said, I like to keep it to axis. Okay, so I will just straighten it, but also you can straighten it by line, or you can straighten it by defining the exact slope. So let's set the slope to -5 per miles. You can have the slope in per miles, or you can also change the unit and show it in percent or in ratio as well. Okay, and let's click apply. And now you see that here we have straight pipe between these two nodes. And also be careful when selecting if you have somewhere branching in the network. So if you select, for example, from this node to this node, but here I have the straight piece. For example, if I select from this node to this node and I straighten or edit the pipe elevation like this node here, this branch node here will not change. So be careful about branching nodes. So that's if you use this option, I like to always go from main node to main node. For example, let's again go from this main node to this main node. I will straighten it, but also I will put this point to be a little bit more deeper, because not just with this function that you can straighten it by line or by slope, you can also precisely define starting or ending depth or elevation. So let's set here depth to be 2 meters. Let's click preview. I like how this looks like, so I will click apply. So that's how you can easily change pipe elevations directly in the profile. And notice how your data table are automatically changing. This blue values in the profile means that this is changed. So when something is black, this means it remained the same. And if something changes to blue, this is just temporarily, this means that that value changed. So let's check other profiles as well. Okay, here you can see if you need somewhere to intervene or to change something. Of course, we have also some automatic error detection where you can search for these pipes that are, for example, too low, but I would like to show you this way, this graphical way. For example, here, maybe we can change this as well. So let's again select this part of the profile from this main point to this main point. We will straighten it, and also we will make it a little bit deeper. Let's also go 2 meters below the terrain. Let's preview it and let's apply it. So that's how it's very, very easy to edit your pipe elevations, either using directly functions for editing in profiles or functions from the data table. Okay, let's now close this. Let's again open draw auxiliary lines, and let's delete these helping lines. I will click delete all, and they are gone. Okay, we set the pipes, we defined the pipe elevations. Let's now also set the manholes. So just like for the pipes, you can go to catalog of manholes, and here you can see all the different types of the manholes. Just like for the pipes, you see that you have different types of the manholes. You can click here to info to check what is the type. So you can have this rectangular manholes. You can have also the circular manholes with or without this entering part of the manhole. You can also have I don't know, manholes with the angles, so it looks like a like this object here, or so basically many different shapes, different sizes, different materials. Everything can be set up here in the manhole catalog. You can even define all the thicknesses for the walls. You can define basically everything, all to the smallest detail. So I will not create a new. It's basically the same like for the pipes. You create a new group, you choose the type of the manhole that you would like to create. You have this info to see how the manhole type looks like, and that's how you can create your own manhole catalog. But let's now set the manholes. Again, you can go to input data, you can go to manholes, or you can go to ribbon and go to function for setting of the manhole in the plan. So let's open the function, and here you can again see that you have all the manhole groups from the catalog. Let's use, for example, I would like to use a rectangular simple manhole. Simple means that it's just a rectangular box without that smaller part for the opening. And I will use the size of the manhole 1200 by 1200. So it will be a square, like a box, a manhole. Then you can also put some manhole label in the profile if you want. I will not. Then you can define some even height above the terrain if you need that. You can also define the depth below the pipe. I will set maybe 0.5. And then also you can define the depth calculation option. So for the depth of the manhole, this is really nice. Of course, you can set the absolute elevation for the manhole bottom, but this is not recommended, because if you then change the position of the pipe, the manhole bottom will stay fixed. So that's why it's always recommended to use this first two options. So the bottom of the manhole will always be in relation to the pipe. So to the outside edge of the pipe or to the inside edge of the pipe. I will always go from the outside edge of the pipe 0.5 meter deeper. Also, you can define the bedding thickness. I will reduce it to 20 centimeters, and that's it. You can then select the whole active system. But like I said, in Urbano, not each node has to be a manhole. So that's why I will go to selection of nodes, and I will select just these nodes where we have branching in our system. So I would like to put the manholes to the nodes where we have branching in our network. Of course, you don't have to use manholes. This is not essential for the water system. Of course, for the sewage system, you would like always to use manholes. But for the water system, you are not obligated to use manholes if you don't need them. So let's click save. And now you will see again the dynamic model of Urbano. Let's zoom to profiles, and everywhere now we have the manholes. You can also redraw the profiles for everything to update. So if you redraw it, you can see that you can choose these pipes to go to the edges of the manhole, or you can inside of the configuration. So like I said, everything can be customized. Inside of the configuration, you can decide if this will go to the manholes or all to the node axis. So now we have the manholes as well. Let's now check the plan, and you can see that by default, you don't see the manholes or the pipes in the plan. That is related to something that we call plan styles or layout styles. This is basically how your system will look like in the plan. And by default, I already said this multiple times, by default, the sections are AutoCAD lines and the nodes are AutoCAD blocks. But this can be changed as well. So here you have some predefined styles. So I can just switch between these. You can double click on it. You can select where you want to apply this style. You can apply the whole system, or you can use different styles for different parts of the network. This is very useful. For example, if you have different types of the network, for example, in the sewage systems, you can use different styles, different visual styles with different colors, different line types to have different style, let's say for gravity networks, and different style for vacuum networks, or different style for pressure networks. Or in the water system, you can have different style for the main distribution pipelines and different style for, let's say, distribution networks. So this is something that can be achieved with styles. But I will not use this predefined styles. I would like to show you how you can create your own style. And also the star is very important with styles, because the star applies to the style which is currently used for drawing. So now this one has a star. If you go to draw, if you go to draw elements, a style that has the star will be applied. So if you create a new style, for example, new style, and you want to use that style, let's call this my plan style, be sure that make that style as a default, as if you want to use that style when drawing. But it doesn't matter, you can even change it or apply it later. It's not that big of an issue. So let's now go to edit, and let's see what you see. When I make it a default, it's not that it will immediately be applied to that is already drawn. But if I now start drawing, that style will be used for drawing. So if I open this, you will see how you can see in plan the nodes and the sections. This can be geometric shapes. So I don't know, circles, rectangles, triangles, points, stuff like that. Or it can be blocks, which is default, or it can be real 2D top view of a manhole, or even 3D solid. So first of all, let's check the geometric shapes. And if you go here in details, you can see that for each node type, for now we have only plain nodes, but tomorrow we will start building our network. So we will add reservoirs, valves, tanks, pumps, air release and washout valves, and so on. So for each node type, you can define for main and for the plain node what will be the color and the size and the graphic style. So like I said, it can be a point, it can be a circle, it can be a triangle, a square, a cross, anything. I will use circle, and for the main nodes I will leave a red color with the size of 1. For the plane, I will also use circles, but I will use the magenta color. So you can see that with this, I'm choosing the same color that I have in the layers, but you can see that you can even override the color defined in the layers. So the colors and the line types and the line widths defined in the style will override the layer setting. So it can be by layer or it can be by style. This will not change the color of the layer, but it will override it. So I will not intentionally, I will not use magenta because this is the layer color. Let's use blue, for example, and I will put a smaller size. Let's say 0.5. Let's click OK. For the sections, I will leave it to be line, and here you can see it can be by layer, or you can change color. let's use blue also. Line width, line scale, line type. I will not use line type by layer. Let's use dash dot. Okay. And now we can click here, update topology that are drawn with this style. You will see that nothing will change. Nothing will change because nothing is yet drawn with this style. Okay. But now let's apply this style. So I will double click on my plan style and I will apply it to the whole network. And now you see, this is not anymore a block. This is now a circle. And this is now a blue line. You see, it's a blue line. It's not by layer, because if we go to layer manager, you will see that our sections are still with color 150 and main and plain nodes are red and magenta. But we override it with the colors from the style and the line type from the style. So this is how you can use styles to differently show your network elements. And this is you see, this is the plain node, which is having different smaller circle with different color. Let's see what else we can do here. Let's now go to edit. Okay, so these are the geometric shapes. Let's now switch to blocks. And now here for detail, again, for each node type, you can define block and scale factor. For the nodes, you can use some of these predefined blocks offered by the software, but also you can use your own custom block as well. Here, I have one custom block that I created. So I will just copy it. It has to go to installation folder. So now I will show you where it has to be pasted, so it will appear in this dialog. So go to C, Program Files, Studio Rs, because this is where the software usually by default is installed. Search for the version. I have multiple versions because I work in development, but you will have only one. And this is my installation. This is the latest version, 10.3. I'm using it on 2022 version. Then inside it will be the language version that you installed. In my case, it's English. Then the version of, not the version of AutoCAD, it's the version of Urbano, because version is the same version for 2021 and 2022. And then here, these are some of the folders. You have to go to nodes. And this is the node blocks that can be used by default. And here I will also paste my block. So just create, and it's important to say that this is a drawing. This is DWG. It's not that the block is already created inside. It's just some drawing. And when the software inserts it in the Urbano, it will become a block. So if you have a block here already in this drawing, then you will have a block inside of a block. So don't do that. Okay, and now let's go here to search. Let's go to, this is for the nodes, and now I will search for my custom block, which is P45 red. And this is how my block will look like. And I will increase it. I will have my scale factor to be 2. And for the plain block, because I'm trying to simulate maybe that for main nodes, I will have a manhole, and for plain nodes, I will not have a manhole. So here I can use these circles, of course, but also you can use, I will use point, which is basically a block, but it's a point. And now if I click OK, like this, and if I click update this and click OK, now you will see that here I have this custom block. As you can see, here is a custom block, and here we have basically a block that is called point. So this is how this can look as well. And you can see this is now a custom block, which is called P45 red. Also, what can be changed as well? Here you can see that this goes up to the center of this block or geometrical element or the real manhole. But let's change that as well. Let's go to edit. Let's go to lines, and here we will say, okay, draw section, but not to the node axis. go all to the manhole rim. So manhole rim or block rim, that manhole edge. So update, let's click OK. And now you see that this looks nicer. It goes to the edges of a manhole. Okay, let's now go to edit plan style. And let's change this to the real 2D style for the manholes and for the pipes. So we will have the real 2D view. And also for the manholes, it asks us here, if there is no manhole defined, what style will be used? It says here blocks. So be sure here for blocks to define how the nodes without manholes will look. So we will not use this. Let's bring back to the defaults. So let's use defaults. I will use these circles for you can use the points also or anything. I will use the H1, which is block of a circle, and here I will use H1 as well, because the blocks will still be used for the nodes without manholes. Okay, and here for the pipes, you can define what will be drawn. And also, so you can draw outer pipe wall, inner pipe wall, axis of the pipe, hatch, you can even hatch pipe wall or everything to inner pipe wall or everything to outer pipe wall. I don't like to use hatch, so I will turn it off. And you can again see that you can override the line type, line weight, and line colors from the layers. But I will keep everything by layer. Okay, let's update this. Let's click OK. And now you see that we have the real dimension of the real manhole that we applied. And here where we don't have a manhole, we have these circles that are too large. So let's go edit. Let's go to blocks, node, because the factor remained to 2. So let's bring it back to 0.5, which was the default. Okay, so that's the style that I prefer to use while designing my network, because I can simultaneously see the shape and the size of the pipes and the manholes in plan. And also in relation to the plans are the 3D style as well. So you can apply 3D style for manholes and 3D style for the pipes as well. And here you can see something that is called simplified view. I will show you what that is. So let's update it. Let's click OK. Now you will see that this will be now drawn with AutoCAD 3D solid elements. You see this is a solid element. And now if we go to 3D view, of course the labels will stay in 2D. Here you can see how this look like. And you can see, because we didn't turn on the simplified view, the software is drawing in high details. It's drawing the outside and the inside walls of the manholes and the pipes. But if you go to style and turn on the option simplified view and also simplified view for the pipes, and if you update this and click OK, now you see that you have just the outside walls. And for the 3D view, for the level of details of 300, I think this is enough, because this is enough to check for the clashes. Okay, so that's it about the styles. Let's now go back, and it's important to say that even though these are 3D solid elements, if you change something, if you increase the pipe diameter, if you change the manhole type, it will automatically update. This is not just some dead 3D solid graphics. This is the live model, but the style that is applied is the 3D style. So let's change this back to 2D view. So we will use the manhole top view, and we will use the pipe contours, meaning the 2D style. Let's click OK. And now you will see that this is now turned back to our 2D view. And the last topic today is the setting of the trenches and the top layers. Again, we have to go to the catalog. And here you have the catalog of trenches and catalog of top layers. Inside the catalog of trenches, again, you can check and define different types of trenches. You have trenches without the step, so we call it simple trenches, and you have double trenches with the step. And you can see that you can define here basically everything. You can define the slopes for each part. You can define the angles. You can define the widths. The widths can be automatic. You can see here, these are the single ones with the defined widths. Here we have width of 1, width of 1.2, 1.5, or you can say that the width is not inside of the catalog, it's calculated. And if this is calculated, then it will be in relation to the pipe that is set for that section. It's calculated, like it says here, according to DIN European standard. So the trench width will be in relation to the pipe diameter. And also I said the catalog of upper layers. This is basically the catalog of the top of the, let's say, asphalt of the road or the soil under which our pipe is going. This is in relation to cross sections, but also to calculate the excavation volumes and different materials that has to be excavated. So here by default we have asphalt and humus. Humus, I like to change this to soil or earth or something, and you can define groups. You can define groups, and for each group you can define different layers, because when we say asphalt, it's not just one layer of asphalt. Or with soil, you can define different layers of soil with different thicknesses and with different colors. So for example, we have here, we have the asphalt first level of 5 centimeters, and I will change the color here to, I will use this darker color. And second layer of asphalt, it will be 7 centimeters, and I will change the color to this gray color. This will be visible in the cross sections and in the profiles as well. And for the soil, we have 20 centimeters of soil with the first level soil 10 centimeters and second level soil also 10 centimeters. Okay, let's now close the catalog and let's define this. So let's again go to input data for the trenches. Okay, and here you can again use the selection options. You can define different types of the trenches for different parts of the network, or you can select the entire network and set the same trench. I will use this single trench with sand bedding, where the width of the trench is calculated according to DIN standard, and the angle of the trench I will use 90. You can also, if you go to the catalog of trench, you can also turn on the phone work as well. So if you want to use phone work for the trenches with the angles of 90, you can use that as well. So that the width of the phone work, it will also go to the report, and it will also be taken into account when calculating excavation volumes. So let's click OK. I will not use phone work. Let's set this trench to the entire drawing. And again, you can see the dynamic model of Urbano. You can see how the graphical part changed. Here we have now the bedding showing here with this hatch. And also you can see that the profile table also changed. You see the trench bottom elevation and the trench bottom depth here automatically appearing calculated. Okay, let's now also set the top layers. So let's go to input data, upper layers, or the top layers. And from the catalog, first I will set everywhere 12 centimeters of asphalt. Let's click save, and let's save this. Again, if we go to our profiles, we can see now how the top layer appeared in the profile as well. Okay, let's now set additionally override. So we have to click here, override the old upper layers with new. And I will say you can go from node to node or from station to station. I will go from station to station because from the raster, I can see that here, from this point to the beginning of our network, we are not under the asphalt. We are under some, let's say, soil, okay? So I will use here soil 20 centimeters. And let's click save. Okay, and now let's check our profile. We can see that up to this point, we have one top layer with different thickness, and from this point on, we have different top layer. And now let's draw cross sections. So to draw cross sections, it's really easy, just like how we draw the profiles. You have different configurations. Inside of the configurations, you can save everything from colors to data, to hatches, to dimensions, everything. So let's just open the one that we will use. I will use this one in a higher scale, so 1 to 50. The cross sections will be bigger than the plan itself. So let's edit it. And here you can see that you can define all the colors, all the hatches, all the data that will go to the cross section, and also all the dimension styles. It is important to say that the AutoCAD dimension styles will be used for these dimensions. So if you want to change it, change you see ISO 25 annotative, or we have our own Urbano, which is predefined for these scales here. So I like to use the Urbano dimension style. Let's click OK. And let's now draw cross sections. Let's double click on this configuration. And now you can draw cross sections in some of characteristic points of the network, for example, in nodes where the top layer changes, or I like to use every n meter along my system. So, and also stations can go by branches or by arrays. I will go by arrays, and I will go every, let's say, 20 meter along the system. And now you have to select, you can of course select the whole system according to arrays, or you can go, for example, by arrays or from node to node. I will select just this array and this array, like this. I will define row spacing and column spacing to be 10. You can also define, just like for the profiles, how you will position them. And you see 68 cross sections will be drawn in a matter of seconds. Let's draw them and let's check them. Now you can see that all these hatches, all these dimensions, all these colors, and the data. So we see which section is crossed, which diameter is this, and on which array station we are. And you can see these different top layers. So this is the soil top layer, and this is the asphalt top layer. Additionally, instead of using this automatic option in characteristic points, you can also just select some stations in plan or in profile and have the cross sections drawn there. And let's now also calculate the excavation report. Here you can have the configuration of data. Here you can set up, for example, what are the depth excavation zones, because it's not the same if we are digging the trench up to 2 meters or to 4 meters or to 6 meters, the prices will be different. So here you can define the depth excavation zones. We will have it by default from 0 to 2 meter, 2 meter to 4 meter, 4 meter to 6 meter. And you can define what data we will have here. So excavation volume, excavation zones, and so on and so on. Sand bedding volume, yes, but concrete bedding volume, we don't need it because everywhere we have the same trench. So I will delete this data. Also, we didn't set up formwork, so I will delete formwork area and formwork volume. Okay, let's click OK. And let's now run this excavation report. So double click on it. Here you can select the entire drawing, or again, some elements. Let's select the entire drawing and let's group this by arrays. Okay, let's save the report. And in a few seconds, we will have this Excel report created that we can open and check it in Excel. So let's check it. And here you can see for each section, starting and ending station, total excavation volume for the entire section. Then you have excavation zones according to the depth excavation zones that we defined. You have the volumes of the top layers that we defined, excavation volume without top layer. You have sand bedding, pipe volume, all the volumes of the top layer, and trench surface area. And everything is sorted and structured by the arrays because that's how we defined it. And if we scroll to the bottom of it, we will see what is most important, and that is the total cumulative excavation and backfill layers data for the entire network. Okay, so that's it that I prepared for the initial training session. I hope you liked it. I hope you have questions, and I hope you would like to test it and try it on your